Today, you're going to learn how to build beautiful gradients. Let's take a look. You can apply this on surfaces of the fictional world you're building, or you can use it to enhance the menus of your game. But you should definitely go for better color choices. I'm just showing you 6 types of gradients, but by the end of this video, you will learn how to build all kinds of linear gradients you can think of, but using 2 colors. Let's get started. Ladies and gentlemen, welcome to Thunderbolt Academy. I'm your host, a seasoned game developer and an amateur rage baiter. When I was starting out, gradients were really hard for me to understand. I didn't like how Unreal didn't give us an option. Oh, okay. Let's not further the ado. Let's launch a new project. I'm using the third person template, so let's open up the content drawer and create a new folder for materials. You can call this materials. Inside this folder, right click and we can create a new material and we can call it MUI linear gradient. No need to be fancy, let's keep it simple. Inside this file, we will firstly change our material domain to user interface. The blend mode will remain opaque. Inside our graph, you can right click and search for vector parameter. This is going to store our colors, so rename this as color A. Now you can duplicate this pressing Ctrl D. You can also hold V on your keyboard and left click with your mouse to create more of these vector parameters, but we don't need so many colors, so let's get rid of them. Now let's call the second color color B. For our color A, I'm going to change it to a yellowish shade. Yellow has good contrast, so let's go for yellow as our first color. And for our second color, let's go for wine red maybe. That goes well with yellow. Now a combination of these colors gets attached to the final color pin of our material node. We can use the linear interpolate function called lerp to combine these values. Let's attach both of our colors to the lerp function and we'll attach this to the final color. Okay, we are supposed to get a gradient, but Unreal is just creating a mixture of these two colors depending on the alpha value. If we plug 1 to alpha, we're getting a full maroon color. And if we input 0, it's the full yellow color. So it depends on percentages. For 0.5, we are getting 50% yellow and 50% maroon. But this is not what we want. We want a gradient that changes from top to bottom, left to right, 0 to 1. And for this purpose, Unreal has specifically created a function called linear gradient. This node has two output pins, U gradient and V gradient. For U gradient, we get horizontal gradient, and for V gradient, we get the vertical gradient. There is a better way to do this. It's by using the texture coordinate function. TextCoord. TextCoord has only one output pin and it bundles both U and V values together. To get the individual values, we use a mask, and if we expand this, R is U and G is V. So if we uncheck G and connect it to alpha, we get our horizontal gradient. If we check G, we get the vertical gradient. It is important to understand these U and V values before proceeding. In our render viewport, V value goes from 0 to 1. The topmost part is 0 and the bottommost part is 1, and U goes from 0 to 1 from the left. So the top left is 0 0 and bottom right is 1 1. So now we want to shade just the top 10% of our surface. For this, we have to edit our V value with some math. We want the gradient to finish at 10%. 10% of 1, which is the total length, is 0.1. So we want to make our 0.1 into 1. How do we convert 0.1 into 1? We divide it by itself. When you divide any number by itself, you get 1. So we take the divide node and divide it by 0.1. And wow, okay, something happened. The gradient is there, in the top 10%, but it's turning black in the bottom 90%. This is happening because the values are going outside the bounds. We can easily fix this using the clamp function, where minimum is 0 and maximum is 1. Let's attach the output of clamp to alpha and hopefully we get it right this time. And perfect. You might be wondering that the bottom 10% must be easy too. We can just divide by 0.9. So let's test it out. This could work, but it's not like how it was at the top. But for this to actually work, we have to shift the value from its current position to 90% towards the bottom. So our new 0 will start at 0.9. And how can we convert 0.9 into 0? We subtract the number from itself, of course. So we will get the subtract node, and we are subtracting 0.9, and then we are going to divide it. And okay, now the gradient is gone. Well, it's not technically gone, it has just shifted towards the bottom. So if the render area was bigger, we could have seen it. We will divide this by 0.1. And it is rendering. There is some shade here, but it's not like our top 10%. And there is nothing wrong with it. It's just our choice of colors that are making it feel this way. If we invert our colors, it will look exactly the same as the top 10%. Let's increase the intensity and divide it by 0.05. Oops, not 0.01, 0.05. Okay, now only the bottom 10% is shaded, but it's shaded with a much higher intensity and it's more noticeable now. Now let's use both our U and V values. Using both our values, we can create a diagonal gradient. Let's get values for U and V using two masks, one for G and one for R. And now we just have to add them. So we'll grab the pin and find the add function and we will add both values. The result of this is then clamped from 0 to 1. And now we can use this clamped value for our alpha. Let me get the final output pin towards the bottom. Let me pull the lerp function down. You can hold the option key and left click to detach any pins, and we get a nice linear diagonal gradient. Let's see what happens when we multiply it with 0.5. Pause the video and take a guess. This is a good exercise. On rendering, we see that we have pushed the gradient further down towards the bottom right corner. Let's bring it back. Now we have two options. We can mindlessly second guess a random number until we are satisfied, or actually sit back and calculate. Let me try some random numbers in. So 0.9 is not working. Let's try a smaller number, 0.1. Okay, maybe we need to go smaller. So let's go from -5 and oh, that's too much. Maybe 1.5. Nope. -1.5. Nope. How about 0.9? Okay, there is some gradient coming. And -0.5. That's the diagonal line. Let me also get the divide node. So we have all possibilities. And after dividing, the gradient is gone again. Let's subtract nothing, divide again by 0.5, and we are back to our original gradient. Let's divide it by 0.1. Okay, now the thing here is that we are multiplying it and dividing it as well. The multiplication and division is basically multiplying by 5, because 0.5 into 0.1 is 5. So let's get rid of the divide node and multiply by 5. So we do see our diagonal gradient here, but it's not at the center. Right now the intersection of the two colors is where the value is 1, and we multiplied by 5, so the rightmost corner is 5. We want to convert 5 to 1, which is easy. We subtract 4 for that. And it's looking so beautiful. If we multiply by 4, we have to do 4 minus 1 because our 1 has turned into 4 because we multiplied it by 4. So we have to convert it back to 1. So we subtract 3. Similarly, if we are multiplying it by 2, we will subtract. Our value is 1 over here and 2 over here. So to make 2 into 1, we subtract 1. And that's how the gradients work diagonally. Now before we proceed, I want to show you the theory behind the math functions that we are doing. This is our render area, and our u values go from 0 to 1 on the horizontal axis and from 0 to 1 on the vertical axis. So firstly, we are going to divide by 0.1. How does this affect our v values? Like this, 0 becomes 0, 0.1 becomes 1, and 1 becomes 10. But our gradient performs only in the 0 and 1 range, so it will work only in the top 10%. Below that, we want everything to be 1, so we use the clamp function, and then our values become 0 to 1, 1, 1, 1, 1, and so on. Our gradient will just be in the top 10% for this. Similarly, for our bottom 10%, these are our v values. We will firstly subtract by 0.9, and this will make our values like this. 0 becomes minus 0.9, minus 0.8, and so on. And 0.9 becomes 0, and 1 becomes 0.1. And then we divide by 0.1. So this makes our values from minus 9 to 1, and 0 to 1 has turned into the bottom 10%. Then we use the clamp function, and that makes our values 0, 0, 0, 0, 0, so on, and 0, 1 in the end. Now let's take a look. Let's wrap up. So this is our linear gradient. We take two colors, we get the text coord function, we get the g value, which is the v value, we clamp it to 0 and 1, we pass this value to alpha, and that's our final color. Similarly, for horizontal gradient, we get the r value, we clamp it to 0 and 1, we pass it to alpha, and that's our final color. For the top 10%, we divide by 0.1, and that's the only difference that we are doing. For our bottom 10%, we are subtracting 0.9, then we are dividing by 0.1, we are clamping it and passing this value to alpha. For our diagonal gradient, we are adding both of our u and v values, we are multiplying it by 5, and we are subtracting by 4, so the contrast is higher over here. We are clamping this value and passing it to alpha. That's our diagonal gradient. And then there is the step function where there is no gradient and it's just two colors. We have 0.5 as our mid value. Everything below 0.5 will be 0, and everything above 0.5 will be 1. And we pass this value to alpha, and that's our final color. Let's see how this looks in the map. I have created 6 shapes over here, and each of these shapes have 6 different types of materials that we have created. We can see in the details menu over here, we have the bottom 10 gradient. Over here we have the diagonal, here we have the step function, here is the horizontal gradient, here is the vertical gradient, and here is the top 10 gradient. And these are our gradients. And we have also applied these same gradients to our UI. These are our UI. This is how it's supposed to look. We have the V gradient, U gradient, top 10, bottom 10, diagonal, and step function. And that's how you create a clean linear gradient inside Unreal Engine. You now understand how U and V values control color from left to right and top to bottom. If this helped you even a little bit, you might consider helping me too by subscribing. I'm just getting started. In the next video, we are going deeper. We will build a proper 3-color gradient material with full control. I'll see you there. Go make something cool now.